In this video, we are going to go one step further and store our implementations in a separate file. If you remember, in the last lecture, we separated things. The declarations were living inside the export block, and the implementations were put below the declarations, but still in the same file. In this lecture, we will be separating those two things and store them in separate files. Here is how our interface is going to look. It's nothing different from the last lecture. We have our module thing here. We have our export that declares our module. We have the preview, which contains things inside our export block. We have a bunch of functions, and we have a class named point here. And all this is going to be living in an interface file. I think it is going to be named math.ixx. And the implementation is going to be living in a separate file. Here is our implementation. You can name it whatever you want, but notice that it is living in its own file. Now, one thing you have to notice when you have an implementation file like this is that the declaration doesn't have the export keyword. And this means that this is an implementation file. It is not declaring any new module. It is just a file that may be adding some capabilities to a module that has already been defined somewhere. And a module is only defined in a module interface unit, as we have here. How do we know this is a module definition? Because of the declaration line we have here. It has to say export module and specify the name of the module. And because we have this line here, this is a module interface unit. The others will not have that export keyword. They may say module and say the name of the module, but they don't have the export keyword. And this means that this is not a module declaration. It is just a way of reusing a module that has already been defined somewhere else. With this out of the way, we have the global module fragment as we have in other module files. We have the preamble where we can do imports, and we have the preview, which is going to be containing implementations. In this case, again, we are implementing the add function, the greet function, the print name length function, and a few methods from our class. Now that you know this, we're going to head over to our IDE and see this in action. Okay, here we are inside Microsoft Visual Studio. I have the project already created, but again, I will show you that for this to work, you have to enable C++20. So let's hop over in the properties and enable C++20 here. And we have to go to General and enable scan sources from module dependencies. We have to turn this on and apply and hit OK. And the files we will be using are stored in the GitHub repository. Again, the project is 48.5 here. So read through this if you want. And you notice that we have a bunch of files. We have the interface file, and we have the implementation file. It is named math.impl.cpp. This is a name I just chose. You can name it whatever you want. And we have the main CPP file. So let's create these two files here in our project. We can go back and say add new item. It's going to be a module file. So math.ixx. We haven't done the implementation file yet. We have our module file, and we need an implementation file. It's going to be a CPP file, so choose CPP on top here and name it math_impl, IMPL. If you do add, you will have the file generated here. If you want, you can type this, but I do recommend using the code from GitHub. And starting from there, you can modify it to be however you want. This is going to avoid typos that would waste a lot of your time. Let's copy this and put this inside our math interface file. So let's do that. So we have our interface again. It's everything you have seen before. Let's go back and grab the implementation file, math_impl, and we will copy this, put this inside the implementation file we have in our editor or IDE. And we need to change the main CPP file. Again, we will grab from the GitHub repository, put it in. So copy, come back here and put it in. We take out whatever we had in by default, and we put in our new code. And I don't think we copied the right file here. Let's go back and make sure we copy raw file, okay, and come back to our main file and put in the content. Now we have the right content. Let's make sure we have everything as it should be. This is an implementation file. Export. This is a module declaration file, so this is right. The implementation file shouldn't have an export keyword here. And we have, what did we do? Math import. This is, the implementation file wasn't copied correctly. So let's go back again and make sure we copy raw file. And we can come back here and make sure we have the correct content inside. Okay, now we should have the correct content, but let's double check anyway. We have the interface file with export module here. The implementation file should just have module and have the implementation for the functions and the constructor. And the main CPP file should import our module and try to use it like we have been doing all along. With this in place, let's try to build and see what we get. Okay, the build is going to be good. Now, one thing I want to draw your attention to that I haven't been doing before, I should have showed you that, is that the first step the compiler goes through is to scan sources for module dependencies. You see here, it is scanning the implementation file, the interface file, and the main CPP file. And once it looks at all these files, it is going to figure out which files depend on which, and it is going to compile the dependencies first. Notice that when it starts compiling, it is going to compile IOStream first. After that, it is going to compile our interface. After that, it is going to compile the implementation file, and after that, it is going to compile our main CPP file. You notice that these dependencies are figured out automatically by the IDE and the build system behind it. I have to say that for Microsoft Visual Studio, it has its own custom build system. I believe it is called MS Build, and it is what is doing all this magic you see happening here. But if we happen to compile manually, like we do with Clang and GCC, we have to figure out this order on our own. Let's go to our README file and see the instructions. We just did what is needed for Visual C++ on Windows. If we try to use GCC, notice now that we have multiple files. We have more files than we had before. We have to make sure to compile the implementation file and the interface file. Notice the order we do things in. We start by IOStream because it is going to be dependent upon by these module and implementation files. After that, we compile the module and we compile the implementation, which is going to be depending on the module. And after that, we compile the main CPP file, which depends on all these things that we compiled before. This order is really important. Notice that it is the same thing we do with Clang. We start by IOStream, we compile the BMI. After that, we compile the module. After that, we compile the implementation. And then we try putting everything together. We put together the main object file. We put together the module file, and then we put everything together into our Rooster binary. You really have to understand this. Now that we know this, we can hop over into our IDE and try to use the G++ compiler. If you don't want to go through the steps, you can just stop here and watch the next lecture, because the remaining part of this lecture is just going to be using different compilers to do what we just did inside Microsoft Visual Studio. So let's go back and use GCC. Let's open a terminal window here. So let's do terminal, and this is going to give us a few terminal windows we can use. They will be already open in this folder here, so we can just do ls to see the content. Again, the meat of this project is made up of these three files: main.cpp, math.ixx, and math.impl. Let's try to compile this with GCC. So we compile the IOStream header unit. This is going to go through. We compile the module file. This is also going to go through. Let's do that. We compile the implementation file. This is the command you use to do that. And we can compile the final binary by putting together all the files to create a rooster.exe binary here. Let's copy this and come back to our terminal inside Microsoft Visual Studio. Run the command. This is going to generate our rooster executable. If we do ls, we should see it right here, and we have the option to run it. And if we run it, we will get the output that we expect here. This is the process to compile and run the code using the Clang compiler on Windows that I have installed. Let's see how you can do this with Clang as well, because we have access to a Clang compiler. Let's copy the command. We will be using the command prompt for this for reasons you already know. We have seen these reasons in the first few videos of this chapter. Let's do ls and clean up. So let's remove any object files that we have. We can do that like this, and remove rooster, and remove the GCM folder that is generated by GCC, GCM, and this is going to go away. Let's hop over to our command prompt. Make sure we grab the first command from our instructions for Clang 16 here, and we can paste it in inside command prompt. So let's do that, paste, and this is going to compile our header unit. We compile our module into a PCM file. That's what we are about to do here. Paste in the command. This is going to give you the PCM file. Go back, grab the command to compile the implementation file. Again, you can notice that it is the same order that things were built in inside the IDE when we used the tools from Microsoft. So you can use that as a way to cheat and see ideas from some other people if you are into that kind of thing. Let's put in the command to compile our main file into an object file. Grab the command to compile our module file into an object file. This is what we do with Clang. And we need to do the last thing, which is going to put everything together and generate a rooster binary. Copy and come back and put that in here. And this is going to give us our binary. If we do dir in command prompt, we should have a rooster.exe binary. If we run it, it is going to give us the output that we expect here. These are the steps you should follow to compile with Clang on Windows. We will also use our Docker container because we have access to it. Before we do, let's see what we have here. Let's do LSALH to see everything in a nice list. Let's remove any PCM files. Let's remove any object files, and let's remove rooster. And this is going to give us a clean slate to start with. And we can run our commands. Again, let's copy from our README file here. We will compile the IOStream header unit. It is done. Let's compile our module into a PCM file. This is something we need to do here. Okay, this is done. Let's go to compile the implementation file. And this is done now. And the next thing we compile is going to be the main file into an object file. And this is going to go through. Grab the command to compile our module file into an object file. And the last thing is going to be to put everything together. So copy the command and paste that in our terminal here. And this is going to give us our binary. If we do LSALH, we should see this in a nice list. And if we run it on Linux, it is going to give us the output that we expect here. This is how you can separate the interface from the implementation and store the implementation in a separate file. I would recommend you carefully watch the instructions we pass to compile, especially now that we have multiple files. For G++, we had to compile the implementation file into a CPP file. For Clang, we also have to do the same thing, and notice the command here. And I figured out these instructions by reading the documentation for compilers and really fighting my way through to get this working. If you have any problem, please do ask. I will do the best I can to help you out. This is all I have to share in this lecture. I am going to stop here, and I will see you in the next one.